So I'm hoping this is going to work okay, so I can kind of show you, I'm using a different recording thing, so I can kind of show you the problems, but also show you the pictures on GeoGebra. So anyway, this is the one that we last finished up with in class, so if you did this in class already, then go ahead and skip ahead. So when we left, we were doing our traces. So z equals 0, I guess I want x equals 0, y equals 0, and z equals 0. So when x is equal to 0, we can see that we have these two left over. So y squared minus z squared over 4 equals 1. That is a hyperbola. A hyperbola that is crossing the y-axis. So if we have our y and our z, it's crossing the y-axis, right? Because the y is in front. If y is equal to 0, then I have x squared over 4 minus z squared over 4 equals 1. That's also a hyperbola. So if I have the x and the z-axis, it's crossing the x-axis at 2 hyperbolas, and this was crossing at 1, that was crossing at 2, because underneath here is a 1. All right, and if z is equal to 0, then I have x squared over 4 plus y squared equals 1, so that's an ellipse. So I have an ellipse with my x and y, going to 2 on the x-axis, to a negative 2, and then 1 on the y-axis. So there we go. All right, so what we have going on here is when we have the x and the y plane, we have like kind of an elliptical shape going to 2 on either side here and 1 on either side there. So I'm going to draw that here. And remember, the drawings are kind of hard. We have hyperbolas crossing the y-axis. So we have like a hyperbola kind of crossing like here and here, right? And we also have hyperbolas crossing on the x-axis back there and over here. So it's kind of hard to see, but this ellipse right here is still there, down there, and above here. So what we end up having, I know it didn't connect everywhere, but we basically end up having this shape like this, kind of an elliptical shape this way, and these hyperbolas like cross in, and you know, so they can like kind of there. So it's kind of like this like little tube that kind of gets wider at the top, and so I'll show you that on the screen now. So we're not looking for anything perfect, but you know, basically something you can figure out what it looks like. So it looks like this. So you can see those hyperbolas right here. Oh, it kind of locked up there. All right, I don't know what happened. There you go. When we're looking at the x equals 0, so the yz, so that would be the green and the blue. See that hyperbola there crossing at 1. And when we're looking at the xz, you see the hyperbola here crossing at 2. You see those hyperbolas. When we're looking down, when z equals 0, you see that ellipse right there. But either way, we have this, it's called a hyperboloid of one sheet. Okay. So hyperboloid of one sheet. And so notice that you've got everything squared. This guy is the oddball because he has a minus in front of him. So notice that it's traveling along the z-axis. It travels along this axis. Okay. All right. So let's go to the next one here. So let's see here. This guy. So if I kind of like rewrite this here, I got y squared over 4 minus x squared minus z squared over 2 equals 1. So I wanted to do that so I could see who's the oddball. Well, these are both negative and that guy is positive. So he's actually the oddball. So something about the y-axis is going to go on here. So if I let x 0, y 0, and z 0. So if x were 0, so if this is basically, that part's gone, you see I get a hyperbola with the y and the z axes. So a hyperbola crossing the y-axis. So a hyperbola crossing the y-axis at 2. So I'm just going to draw that, 2 and 2. So hyperbola. If y equals 0. Well, if y equals 0, that can't happen. Because if y were gone, then how could things that were negative add up to a positive 1? So that can't happen. Because you see, look, y is never 0. The thing's going to be on the sides. And if z equals 0, this is gone. I get a hyperbola, but it's kind of going the other direction. It's still touching the y-axis at 2, but instead of being up and down, it's like out across. So it's doing the y and the y and the x plane. So it's coming like out this way. So I'll show you in a second and just finish these off right here. But they're going to be like two little bowls. And so when you look at that, so let me turn the next one on. Oh, GeoGebra, why are you messing up on me? Let me just go back here. I'm just going to close that one, start over. Okay, I don't know why it just doesn't work this first time I do it. So anyway, there you go. There's your two little bowls in a way. I guess they're a little more pointy than we drew them. But you see there's your hyperbola that way, there's your hyperbola this way, and y is never 0. Okay? So do notice also it's going along the y-axis. That was the oddball. Okay, that was your oddball part of the equation, the odd man out. He was the one that was positive while everybody else was negative. So along the y-axis. And this is called a hyperboloid of two sheets. Okay, like two little bowls, or cups, I guess you could say. All right, so the last one here. On this last one here, we have to reformat it a little bit. So I have to complete the square a little bit. Let's gather our x squared minus 6x, leave a little space there, plus z squared. So I'm going to take that 2 out of my, oh, we can just leave it actually. So 2, there's no other z's here, 2z squared. So let's see, so I got that guy, that guy, that guy. I'm going to have a minus y and a plus 10. All right, so we're going to have to add 9 here because half of 6 is 3, 3 squared is 9, and I'm going to add 9 on the other side. So I have x minus 3 squared. I'm going to keep my plus 2z squared. And I think what I'll do is put the other stuff on the other side, y plus, let's see, minus 1 that'll be. Okay, because the 10 comes over minus 1. Okay, so let's do our traces. X equals 0, or basically that 0 is out here. Y equals 0, z equals 0. Okay. So if x was equal to 0, so I'm going to say instead of, basically, by saying x equals 0, we're kind of saying that this part's disappears. That would be when x equals 3, but just work with me here for a second. So I have this shape right here. That's going to be a parabola. And remember doing y and z, and it has to hug the axis. Remember when you have y equals x squared, it hugs the y-axis. So this is also going to hug the y-axis, but that's going sideways now. Okay. All right, y equals 0, so basically this part's gone. So I have two things squared adding up to a negative 1. So that will never happen. Okay. Z equals 0, meaning like this part is gone. I also get a parabola. Y, and then you have x minus 3 squared. So just a normal parabola where you have, oh, let's see, right 3, and then this 1 would be over here, so plus 1. So right 3 up 1, so right there. Okay. All right. So this spot right here is 3 and 1. All right. So if x were 3 and y was 1, these things would zero out, and you'd have z equals 0. So I can go ahead and confirm that that's the point 3, 1, 0, because if x were 3 and y was 1, these would both be 0. I'd get 2z squared equals 0, so 0. So if I go to the 0.310, so 1, 2, 3 over 1 and nothing right there. So what's going to happen here is I end up getting a parabola shape, right? This is like my parabola here, but it's like kind of going up like this, right? Because it's like, this is my x and my y, and it's kind of twisted over here. And then I have this other parabola for the y and the z plane, so that's kind of coming up and down. And so what you end up getting is just like a single little bowl shape right here. Okay, so if we go kind of look at that over here, hopefully my GeoGebra will work. Please, GeoGebra. There we go. All right, so that's the shape right there. And you can see, you know, the little vertex right there, 310. We have a parabola that way. If I look at it with the y and the z, so if I look down on it, it's a parabola. That's the y and the x. If I look at the z and the y, so this way, kind of a parabola, but more like an ellipse, but whatever. All right, so there we go. So we're just going to finish up with this last little summary page right here. So this summary page right here, I have already kind of filled out nicely, so I'm just going to let you copy that down and kind of like look at it as I reveal it. So, and just pause the video and if you need to, if it doesn't, you have to write this down. So anyway, so some generalizations to notice. All variables are squared, you get something double-sided. One variable not squared, you get something one-sided. Okay. All right. You got to let x equal 0, that's your yz plane trace. Y equals 0 is your xz trace, and z equals 0 is your xy trace. All right, so let's start over here. So in this category on the left here. So this little scenario is meant to be where all things are squared, and it can be added, subtracted, whichever. So your first case is when you have all positive. If you have all positive, everything squared equal to 1, or it doesn't have to be 1, but you get a sphere or ellipsoid. Okay. If it's not all equal to 1, then that's when you have the sphere, and you have your radius squared over there. All right. So everything positive equal to 1, you get a sphere or ellipsoid. Okay. If you have two positives and a negative, but equal to 1 over here, then that's where you start having a hyperboloid of one sheet. And it's going to hug the axis, that's the oddball. The oddball, the one that's negative. He's not like everybody else. And then when you have two negatives and a positive, that's where you get a hyperboloid of two sheets. And it hugs the oddball. So it's going to be along the axis, that's the oddball. So that's where the cups are going to appear. So like this one, this first one must be Z because it's on the Z axis. Okay. All right, so going to the middle section here. So then this could be any letter is all by itself. It's all by itself and it's not squared. So I did it with like Z, right? So if you have Z equals x squared over a squared plus y squared over b squared, that's going to be your elliptic paraboloid. So like if you cover them up, you got a parabola, you got another parabola, it's going along this axis right here. It's hugging that axis. It's like curling up to meet that axis. Okay, so that's when it's addition. When it's subtraction, that's your worst case scenario. That was that saddle that we did earlier. That was a hyperbolic paraboloid. So look, you can see that you have a positive parabola, and then when you cover that one up, you have a negative parabola, so they're like turned and going different directions. And so that's when you know you have a hyperbolic paraboloid. And whichever one is positive here, that's the axis you're going to be kind of like sitting on, like if you were like riding a saddle. But okay, we won't have many of those. And our last scenario here is if you have something squared, but it equals the other two. Now notice here there is no constant. So this is kind of similar to this guy over here, but there was a number in there. So there was some kind of number. It doesn't always have to be 1. But this guy here, there's no number. There's only variables. They're all squared, and you got one oddball over here. and the other two there. So anyway, so that's going to be your cone, elliptic cone. It can be circular in nature if the A and the B match down there, but it's going to be elliptical if the A and the B don't match. And this will be going along the z-axis because Z is the guy over here by himself. Okay, so hopefully that helps you, and we are going to, in class next time, do this little like you know, kind of quiz ourselves on like what's going on there. Just look for some things, and so see you in class. Bye-bye. Bye.